Welcome Algebra 2 students to our video on solving polynomial equations. And we're going to see imaginary numbers here again. We haven't seen them in a while, so you see even though it's really just like the variables u and I, but it's so cute. I love that particular meme. But anyway, let's jump in and start solving some polynomial equations. Okay, so we're going to be doing the stuff at home here. You're going to be doing the stuff without a calculator. I'm going to show you some cool tricks with a calculator. There are going to be a couple of moments where I'm going to sketch a graph for you so that you can see what that graph would look like in that circumstance. But we're going to be looking at, this is paper and pencil approach, and then in class it's going to be calculator approach partly. If x minus a is a factor of a polynomial, then the polynomial has value 0 when x equals a. If a is a real number, then the graph of the polynomial has that value as its x-intercept, that a. To solve a polynomial equation by factoring, we're going to write the equation in the form where it equals 0. So it usually means getting everything to one side. Then we're going to factor it and use the zero product property. All right, let's get started. Okay, so here's the first one. It's 2x cubed minus 5x squared equals 3x. Okay, so we're going to get everything to one side, so we're going to subtract, let's see, get the right color here, subtract 3x from each side, leaving me 2x cubed minus 5x squared minus 3x equals 0. And now we're going to factor this. So always start off with a GCF. I'm going to take out the GCF of x, which leaves me 2x squared minus 5x minus 3 equals 0. And then we're going to factor the trinomial here. I do this by grouping. We want factors of -6 add up to -5. That's going to be -6 and +1 minus 6x plus 1x. Alright, x right there equals 0. So we're going to have factor out of 2x, leaving x minus 3, still an x out front, plus 1 times x minus 3, and the parentheses for the whole thing, x 2x plus 1, x minus 3. Okay, let me double check my math real quick. Okay, we're good to go. So now we're going to use that zero product property. And we have 3 factors. So we're going to set x equal to 0. That's one factor. Don't forget about that x by itself. That one counts. 2x plus 1 equal to 0, giving me 2x equals -1, x equals -1/2. And we're going to set x minus 3 equal to 0, giving us x equals 3. So we got 3 solutions, -1/2, 0, and 3. So we've used factoring, we used the zero product property. So at this point it hasn't changed very much from dealing with quadratics. Next one. Okay, this time you see your degree is quite a bit higher. So again, we're going to go ahead and get everything to one side. This time we're going to subtract 6x cubed from each side. So we're going to get 3x to the 4th minus 6x cubed plus 12x squared equals 0. Again, we're going to take out a GCF. This time it's 3x. So when you take out that GCF, 3x squared. When you take out that GCF, you've got x, let's see, that's going to be x squared minus 2x. All right, plus hold on. Sorry about that. I confused myself, had this random parentheses, and then the darn thing wouldn't let me erase it. So I scribbled it out because I don't want to go back and rewrite everything and have it double up like it's been doing. It's not the best app in the world, but we're going to make do. Anyway, let's keep going. Okay, and again, this time we use that zero product property. So you can take, and you can actually divide off the 3 altogether. I could have done that in the beginning, actually, would have been even easier. And we're still left with the x squared out front, so x squared minus 2x plus 4 in the parentheses, and it still equals 0. So when we set x squared equal to 0, we get one value of x equals 0. You take the square root. You don't have a plus or minus because the square root of 0 is just 0. So that's one solution. All right, then we've got this. Now this is not factorable. There are no factors of 4 that add up to -2. So we have to use the quadratic formula for this. So even though it's not the entire equation, we can use it for just this part, this factor of this equation. So quadratic formula here is going to be, actually let me go up quite a bit higher. There we go. Okay, now the opposite of b plus or minus square root of b squared minus 4ac all over 2 times a, which is 1. All right, 2 plus or minus square root of 4 minus 16. So minus 16. So that is going to be negative. It's going to be imaginary or complex, depending on which one you like better. -12 there. All right, so -12, that's -1 and 4 and 3. Those are the 3 factors I want to think about. Taking the square root of that, I can take the square root of -1, that's going to be I. I can take the square root of 4, that's going to be 2. I can't take the square root of 3. You'll notice the 2's here are going to cancel. Okay, and only because you have 1 on both sides of the plus or minus. And you're going to have 1 plus or minus I root 3. Okay, so we have how many solutions? I think we have 4. Well, here's how this works. This is a double root, so the 0 kind of counts twice as 2 solutions. Then you've got 2 solutions here, because the total number of solutions is the same as the degree. The degree equals the number of solutions. And this problem has a degree of 4, so it's got 4 solutions. The 0 would kind of be counted double. And so the way you would write it, kind of running out of space here, is 0, and then you can write 1 plus I root 3, comma 1 minus I root 3, writing them out separately. Awesome. Let's continue with a little bit more fancy factoring. Okay, so these are our 2 that are similar to what we just did. I want you to copy it down. I want you to try it a little on your own first. You're going to get both imaginary and real answers for this first one. So let's give it a shot. If you're not going to pause it, that's fine. Go ahead and keep watching. Let me go ahead and jump in and do this problem here. So we've got these 2 factors. I'm going to set them equal to 0. X squared minus 1 equals 0, and x squared plus 4 equals 0. There's 2 different ways I could solve the first one. I could factor it, or I could isolate x. So I'm going to isolate x. X squared is equal to 1. So when we take the square root of each side, we get x equals plus or minus 1. And yes, we do have to remember both. Let's do the same thing here. Isolate that x squared, giving me x squared is -4, which I should recognize there, complex answer. I'm going to get a plus or minus answer. The square root of 4 is 2, and the square root of the -1 that's in there, 4 times -1, is I, plus or minus 2I. So the 4 solutions for this one are -1, +1, 2I, -2I, and +2I. Right on. Okay, next one. I worry about some of the feedback because I have to move the iPad, and I apologize. But I'm trying not to have too much feedback in the video. Let's isolate, not isolate, but let's get everything on one side. So when we subtract the 5x to the 4th, we're going to get this. And when we add the 2x cubed, we're going to get 6x cubed. All right, so I want factors of, let's first of all equal 0. First of all, GCF out, x cubed, leaving x squared minus 5x plus 6. Oh, that's factorable, so this isn't bad at all. So we have our x cubed, factors of 6 that add up to -5, -3, -2. Set those factors equal to 0. X cubed equals 0, so x equals 0. X minus 3 equals 0, so x equals 3. And x minus 2 equals 0, so x equals 2. So that's 0, 2, and 3. So no imaginaries on that one. Okay, moving on. Okay, so this one's going to have a little bit of a difference. We've got the degree of 4, but you notice you're missing that cubic term. So let's start the way we normally do. Isolate, or not isolate again, I keep saying that. Get everything on one side. Okay. Now, this is a little different, isn't it? So we've got x to the fourth and then x squared. Well, it's analogous, though, to x squared being this term here, this being an x squared term, and this being an x term. And what we're going to do is we're going to pretend that x squared is equal to the variable a. If x squared is equal to a, what would x to the fourth be? It would be a squared, because you'd multiply x squared times itself to get x to the fourth, so a times itself to get a squared. All right, so let's replace the x with our new expression. So a squared minus 3a minus 4, and pretend that's what we're factoring. So what are the factors of negative 4 that add up to negative 3? That's right, they're negative 4 and 1. And now that I've gotten to this point, put your x squared back in for the a, and you're going to notice something. Like, hold on, I can still factor this first binomial. Or I could use that solving for isolating the variable, the zero product property. Just remember to get both your solutions. So we got x squared equals 4, so that means x equals plus or minus 2. And then we got x squared plus 1 equals 0. And when we subtract the 1, we get x squared equals negative 1. Square root of that, x equals plus or minus I. So you got plus or minus I and plus or minus 2. I don't know what happened to that there. Got a little confused. Okay, moving along. There's only this slide and I think one more after this, and this video will be done. Okay, this time we're going to, again, get everything on one side. And you should very quickly notice, oh, fabulous, it's a difference of cubes. So that's going to be x minus 1 for the binomial. X squared plus 1 times x is x, and then 1 squared. It still equals 0. And again, this is one where we can deal with this with a zero product property here. But with this, because it's not factorable, we're going to have to use the quadratic formula. Opposite of b plus or minus square root of b squared minus 4ac. And again, we're going to get a complex number there. So negative 1 plus or minus. So this is 1 minus 4, or negative 3. Sorry, I don't know why I made that fraction bar and that radical sign quite so long. There we go. Okay, so the square root of negative 3 is I root 3. So I have negative 1 plus or minus I root 3 over 2. And you can express that in a couple of different ways. You can actually leave it that way for most of your teachers probably that you're going to have. Don't forget we have this 1 over this guy over here. Remember him? Hello. Okay, so we have the 1. The most correct way to express this monstrosity here is to separate it into two fractions. Negative 1/2, and then again into two terms, one with plus, one with minus. Negative 1/2 plus I root 3 over 2, or root 3 over 2I. Usually you put the I in front. It really doesn't matter, I don't think. And then negative 1/2 minus I root 3 over 2. Okay, last slide of problems. Okay, so the video is getting lengthy, so I want you to pause it. I want you to try these, and then I want you to start the video again. But rather than write it all the way out, I'm going to, I should say videotape writing it all the way out. I'm going to go ahead and write it all the way out and briefly run through it with you with the laser pointer tool. All right, pause it. Try it. Please. Pretty please. Thank you. All right. And ta-da! Okay, let's go through this rather quickly. Get everything on one side here, and again, because it's an even, it's just like a difference of squares, each of which can be solved using the isolating the variable method. So you end up with plus or minus 2i and plus or minus 2. Next, when we get everything together, we factor out a GCF, and the rest of it's factorable, and we get negative 4, 0, and 2. And on the third one, we go ahead and distribute and simplify down a little, and we end up with a difference of cubes. A difference of cubes, which we then factor, and then we have to use the quadratic formula for the trinomial part. And we get 2 and negative 1 plus or minus, I root 3. I forgot the I. hold that thought. There it is, I root 3. And that's all she wrote for tonight, folks. I hope you enjoy. I'm exhausted. I'm going to go crash, so I will see you tomorrow.